Hello, everyone. This is Brad Burwald. I'm just giving everyone a notice that we'll get started in about 1 minute as we allow everyone else to join the webinar. Okay, talk soon. Okay, everyone, we're going to go ahead and get started. So welcome again to another of Morningstar's webinars. And this one is featuring one of the newest members of our energy storage partner program, and that is Universal Power Group, UPG Battery. And we will be going over their battery products as well as Morningstar's support of lithium. But before we get started, I'll just go over a few housekeeping items. Again, thanks for joining us today. And if you have questions, you can go ahead and put them into the questions box in the webinar dashboard, and we'll be happy to review those throughout the webinar as well as answer them at the end of the presentation. And if you do ask questions and it does not get answered during the session, we'll be able to email questions to you after the fact. We like to give everyone a complete response. We are recording this webinar, so it will be available shortly after the end later on today. And we generally will share that out to the registrants as well as post it to Morningstar's YouTube channel for viewing anytime you'd like, or reviewing if you want to see it again. The slide deck is attached in PDF format in the handout section of the GoToWebinar dashboard. So if you would like to grab a copy of the slide deck for later viewing, please take a look in the handout section. And then we will try for no more than 1 hour of time. And we think we'll be well under that, including questions. Okay, so with that being said, again, I'd like to welcome everyone, and we will go ahead and get started. Over 80 years of combined energy storage success with UPG and Morningstar, and Morningstar's Energy Storage Partners Program. So joining me today, again, my name is Brad Burwald. I'm Senior Product Manager, but our guest here is Bob Santella, the Vice President of Sales with Universal Power Group. So Bob, welcome, and thanks for joining us today.
Thank you very much, Brad. We appreciate being part of the ESP program, and we look forward to the webinar today and everybody that has joined. So thank you very much.
Okay, great. All right, well, we will get going. Briefly, an agenda for everyone so you can see some of the things we're going to be covering. Of course, who is Morningstar, for those not familiar, and also what is the Energy Storage Partner Program? And then we'll also get an introduction and company overview from UPG. And then they're going to be going through their lithium battery technology and models, some of the features, and some really great success stories with performance data on their batteries performing in off-grid markets, how the batteries and controllers fit into a system. And then, of course, since UPG has entered the program, we have configuration files for support. So I'll be giving a brief tutorial on how the UPG battery settings are loaded into Morningstar's products. And then lastly, a little bit about some communications and data logging. And then we'll wrap up with questions and answers for both the companies. Okay, so to get started, Morningstar, we have over 4 million products in the field since our incorporation in 1993. So we've been doing this for quite some time. We are distributing our products throughout the world in over 100 countries, and really our focus has always been on industrial applications, mission critical, where uptime is a really key need for the site. And we sell into a variety of markets and verticals. Residential, that would be home-based systems. Rural electrification has always been a passion as well in parts of South America and Africa for bringing electricity to rural areas. We do commercial installations and also a keen focus on industrial, telecommunications, oil and gas, and security. The mobile and marine market, also an area that we cover. And we like to think of ourselves as the charging experts with a pretty broad line of products that cover both PWM as well as MPPT charging technologies. And we're also proud in our long history in the industry of having the lowest failure rate. So Every day at Morningstar, we get inquiries from a lot of integrators, designers, power system engineers, and of course, lots of users that want to put our products to use. And I would say 30% and more, maybe now growing, of these inquiries are asking about the use of lithium technology with our charge controllers. Because if we want to be the charging experts, we really want to support a wide variety of chemistries, and lithium being a key one, of course. And one of the most common questions is they want to know, what settings can they use, but also, especially with OEMs and integrators, they're not just building one system. They may be doing an entire deployment, and they really need that confidence of having the right settings for the right batteries, especially, with lithium being a very long life product, they want to get it done right. So having a manufacturer vetted charging setting that's been agreed upon is a key need for the ESP program. So what the ESP program does is we work with partners such as UPG and others, and we work out all the details with their applications engineers, their engineering and R&D teams, as well as Morningstar's technical resources. And we make sure that the interoperability is well-defined, documented, and tested. And then we make those available on our website for easy loading into our controllers. So it really gives confidence in the system. It makes integrating the system more easy because the product is preset for a certain battery, and it really gives the best documentation because we provide documented guides for each product. Okay, so that is Morningstar's overview, and with that, I will hand the presentation off to Bob.
Thank you very much, Brad. As we talk about UPG, we kind of want to just give a little bit of overview because UPG is just not a battery company. We have a plethora of value-added solutions that we bring to the table for all of our customers. Number one is we are ISO 9001 certified for all our processes within UPG. And where that really plays into effect is we have a FIFO system where the first inventory in is the first inventory out. So we make sure that all of our customers have fresh batteries and the latest batteries that we have in stock. It also allows us to have quality assurance and quality control within our parameters, so we know how long the shelf life of a battery is sitting in our warehouse and when it goes out of our warehouse. We have 3PL capabilities where we have capability of asset tagging, UPC creation, and any type of label a customer may need. We have the capability of doing that right in-house in our 220,000 square foot facility in Coppell, Texas. We have been around for over 50 years and are in the forefront of SLA and gel batteries, as well as our new launch in 2021 of our LFP batteries, which we will talk about today. And some of the other value-added benefits of dealing with UPG is we have an in-house engineering department that has a Maycore equipment right on site that is used for detailed evaluation of batteries and energy storage devices. We have a marketing department on site that can help with dual branded literature and also any custom promoting or materials that may need to be required for sale to the channel. And overall, we have power sport and battery back solutions as well. SumBar is a cross-section of our customers. We do spec'd-in OEM business or UB branded business with all of the customers that are listed below, which is we're very proud of all of our customers. Next slide. So some of the applications that we create are SLA and gel and LFP batteries. Is everything from medical, consumer, reserve power, oil and gas, life safety, marine batteries, breakaway kits for trailers, and also power sports for golf. We have golf carts and also motorcycles under the Kinetic brand name, where we do car audio and power sport batteries. Next slide. As we're talking about our lithium iron phosphate product line for 2021, we've developed 5 products that we've launched this year. Our showcased item is our LFP 121030 UPG LFP battery. It's a 103 amp battery that we put in a Group 27 case. This will be the showcase feature product for today. We've also developed an 18 amp, a 12 amp, a 6.45 amp, and also a 12.6 amp battery, which we will go into the configurations of each and how they apply to all the applications out into the field. Next slide. Some of the benefits of lithium iron phosphate LFP technology is you get 10x the cycle life, 2.5 times longer shelf life. Self-discharge of these batteries is only 1% per month. We have a battery management system on the top of every one of these batteries that was designed in-house at UPG. Lithium iron phosphate batteries charge 3 times faster than a sealed lead acid battery. Obviously, the ultra lightweight, it's less than half the weight of an SLA battery. And what we're going to show you today is these are actually ideal for extreme environments. Next slide. What we've done is for an SLA, we've documented an SLA as the discharge currents increase, the amp hour capacity decreases rapidly. So you can see where an SLA starts at 100%, and over time it quickly discharged to about 40% capacity or 60% depth of discharge. Where an LFP battery will start out at 90%, and we start these, they are never fully charged per regulations of shipping LFP batteries, but you can see the discharge only goes down to about 75%. And this is a perfect example of how an LFP battery works versus an SLA battery out in the field. Next slide. Excuse me. What we did is we put a runtime comparison for UPG LFP batteries versus SLA batteries. Number one, every one of these batteries has a battery management system, as we discussed earlier. But when you really look at it, is when we took a look at what we wanted to develop first, we wanted to do some SKU rationalization for applications and then also for SKU count for all of our customers. So as you can see, as we developed a 6 amp battery, the runtime of that battery is 1.14 hours with a total runtime of 2,280 hours. Compared to a 7 amp and a 9 amp SLA battery, you can see the differences in not only the runtime, but total runtime of the lifetime. And it's pretty dramatic. So what we've done with a 6 amp battery is basically taken out 3 SKUs and have one solution for all those applications. All 3 of these batteries do come in the same size case, which is the 7 amp, 8 amp, 9 amp size case, which we've made into an LFP 12 volt 6 amp battery. As you go forward, you can see where our 12 amp runs against an SLA battery, and also it will outpower an 18 amp battery as well. We've designed our 12 amp battery in a 9 amp case as well. So you have a smaller footprint for all of our lithium iron phosphate products. From the 18 amp battery, what we've done from a runtime of 49 minutes versus a 26 amp battery, which is 43 minutes, and a total runtime of 1,600 hours versus 170 hours. These are dramatic time changes, and the length of the runtime of these batteries is phenomenal. One thing that we're going to show and share with you in a few slides is we actually have field tests out in the field on an off-grid sites of how these batteries work. And the battery that we tested is the flagship and the showcase battery for today for off-grid systems is our 103 amp battery. It comes in a group 27 case with internal threads, and you can see the total runtime versus 110 amp SLA battery of 4,600 hours versus 400 hours of a sealed lead acid battery. Well over 10x the timelines. Next screen. So when we talk about temperatures and lithium iron phosphate and lithium products, everybody, the first question they say, will it last at 0 degrees? Will it last at 100 degrees? And they really, the comparison is how much longer does it last versus an SLA battery? What we did 3 years ago is we took this 103 amp battery and put it out into the field, and we've done 3 years of testing. And all the batteries that we've put out into the field, there have been 0 failures in the field. The field sites have been in North Dakota, West Texas, South Texas, and West Virginia. And one of the key items that we want to bring to everybody's attention is the low temperature specifications is based on the internal cell temperature of each battery, not the ambient temperature that it is outside. And that's a big difference. And we're going to show you the attributes to our 103 amp LFP success. One, all of our battery cases and LFP cells are potted with a heat-cold resistant compound, which helps the cells stay in place, but also insulates against the heat and the cold. We use 4 prismatic cells, which are layered cells instead of cylindrical cells. The reason being, for balancing, we only have 4 points versus 108 points in our competitors' batteries for points of failure. Again, we have a Group 27 case, which is a smaller footprint. It has less space excess. We've designed the BMS in-house, as I mentioned earlier, and the mean time before failure is 10 years on our BMS boards. Additional enclosure insulation measures have been implemented, and we tell our customers about that. One of them is underneath the battery in heat or cold, we put rubber mats for thermal insulation mats, which helps that bottom of the enclosure not becoming a heat sink or a cold sink. And also the insulation pads, some rigid pads that you can install inside the enclosure that help keep the ambient temperature out and keeps this battery warm and running all the time. Next slide. We have, as they call the proof is in the pudding, we have 60-day trends from the field, and this is up from December 28, 2020 through February 26, 2021. This particular graph is from South Texas. We had a huge cold front come in through Texas during the time frame where the red arrow is, and you can see the lows of the voltage of where at night and when the battery is discharging, where the voltage stays at 13.2, and the spikes are when the panel is working and that battery is charging and you have full charge on that battery. What's impressive about that is just the balance and the stability of how a lithium iron phosphate battery runs in the field. Next slide. Here is a graph of West Texas, which got to over 0 degrees. It was the coldest in West Texas in over 90 years this past winter. And you can see where the battery actually dipped down, but it stayed running and it was over 13 volts, which the depth of discharge stayed at a great level, and the stability of the battery was running completely through the whole cold front. Next slide. North Dakota. They also had, it was ambient temperature of -7 during this, where the arrow is, during this time frame. Now, the ones in North Dakota did have rubber mats and were insulated with that rigid foam inside the enclosure. So it had some extra cold resistance in it. But again, in that kind of weather and that type of weather, we had nothing but 100% success with this battery running out there. And again, all these batteries you're seeing these trends for have been in the field for over 3 years. These are the same batteries we implemented in March of 2018. We haven't had one swap out. We used to do these sites with SLA batteries, 110 amp, and we would have at minimum have 2 per year at each site go out, and sometimes even 1 every other month in some of the extreme colds and heats in some of these places. Next slide. And our last trend is from West Virginia. They had their cold front, a big cold front that came through in January, and you can see where it dipped down, and then it comes right back to stability. And again, it's running over 13.3 volts and has been just a stable product throughout, and just runs fine in cold and heat. Next slide. And we added this. This was the first graph when we went from SLA to LFP, and you can see the dates on there. It was 3/12/2018. This was the graph before lithium with an SLA 110, and then how our lithium iron phosphate battery was running all the way through July of that year. This is a great example of the difference on how these batteries perform out in the field and off-grid applications. Next slide. The biggest part of an LFP battery is really you're going to sell a return on investment. We put together a 10-year snapshot on an LFP versus an SLA versus a gel. And I'm using retail cost for all these batteries. We know we've only used one battery on off-grid sites for the LFP. LSA, at a minimum, we were doing 2 per year, one during the winter and one during the summer where they'd have to change them out. And a gel usually would last through the year before you'd have to change out a gel battery. We've calculated the yearly hardware cost, the yearly maintenance cost. Now this fluctuates, and I used a very conservative number here of $200 per swap out of battery per year. We have some customers that have told me due to insurance, truck, labor, time, etc., that sometimes a swap out of a battery can be in the excess of $400 to $500. We use $200 a battery. By total of year one, over an SLA, you've already got your cost of return on an LFP battery if that was being installed in that off-grid site. And as you go to year 2 and year 3, and the biggest is total of year 10 of how much money you'd spend on that site or off-grid location if you just went with an LFP versus an SLA and a gel. This is really the selling point, we believe, of LFP. We have in the industry the only one that has field test data that we're able to bring to everybody. And we believe it tells a really good story on how lithium can and should replace SLA out in off-grid solar sites. Next slide. Some of the product roadmaps, products you're going to see from UPG over the next 18 to 24 months. Everything for 12 volt, 18 amp with nut and bolt and internal terminal solutions, all the way to 24 volt 8D solutions and everything in between. These are demand driven products, and we look forward to bringing these to you and showing you as we launch these products into the channel and building the breadth of product of our LFP line. Next slide.
Okay, thanks, Bob. I will go ahead and cover things from here, and I really appreciate getting all that information. And I got to say that the data is really compelling here, because having that, as you said, the proof of the system working, and not only these temperatures, but also one of the things I touch on a little bit is the voltage range of the batteries. And a lot of off-grid sites, the industrial applications, they really value that narrower operating range, so it's not cycling so much, because a lot of loads prefer, especially in the 12 and 24 volt range with industrial oil and gas applications and others. It's extremely helpful. So well, thanks. I'll go ahead and cover a few things here, and then now speak to Morningstar's technology and how we try to complement the choice of the LiFePO batteries in these applications. So one of the important slides we wanted to cover here is these are kind of the characteristics of LiFePO batteries as we see them, and the things that we do with the charge controller that kind of take these into account, so that we can not only charge them in the correct way and with the right voltage and current settings, but also deal with some of their unique qualities, most of which are extremely beneficial to the site. So the first is when you do make the transition to lithium batteries, as Bob said, the BMS is integrated into the product. And that's usually a standard offering, and it's built in and custom developed for that kit, including the cell technology, in this case, the prismatic cells. And having that BMS in there is going to ensure, proper charging and balancing. And you just want to make sure, when you set up your charge controller settings that, that takes that BMS into account. I know that some lithium batteries have the ability to disconnect if they were too deeply discharged, but with proper LVD settings on most charge controllers, that is not really a concern, and the BMS is going to take care of everything else beyond that. The second is the narrower voltage range, which in this case is a really big benefit, because you just get less fluctuation. And what I mean by that is with lead acid, you can see in the 11 volt range, as you approach a low voltage disconnect, and during cold temperatures, you could see as high as maybe in the 15s. and that's a pretty wide range. But a lot of DC loads really prefer a narrower operating window. And as was shown earlier on that graph, you can see how much narrower that is, and that's better for the site overall. Um, there are some concerns about the colder temperature charging. Again, the thing to note is it's only the charging that can occur at those extreme cold temperatures. Lithium can still operate, in a very cold climates. So really, if it's just a brief period, the product can get through that. And as Bob explained, with the right type of mechanical design of the battery, you're really not seeing that internally in the cells too often. And even if you do, there is some small amount of self-heating. They get to a higher operating temperature, and you're pretty much good to go. So you can see that they have a really broad range of environments which they can work in. You want to be sure, as I said in the first point, that the LVD point is really accurately correlated to the state of charge of the battery, because the battery will protect itself from that kind of chemical death if it was drained to 0%. And the BMS will disconnect before, and you want to make sure that your LVD setting on your charge controller is set above that value. And that usually is a standard setting in Morningstar's products that's 20 or 30% remaining state of charge. You've got extremely low self-discharge with lithium batteries, so extended periods of time are okay, but you might want to be sure that systems that aren't frequently used are basically going to be okay during that extended period of float, and that's something that we also put into the charging stages of the battery itself, because with lead acid you're going to see a much higher discharge rate if it's just standing and not being used. And lithium, I think Bob had said 1% per month, which is really minimal. You also see much higher energy density, so that high charge and discharge rate, I think 3x from the earlier slide, is a really important thing to note, because it gives you that speed to recharge the battery quickly, whereas lead would, suffer and probably be much too high a rate for it to handle during those quick recharge times. And then, of course, the higher upfront cost of lithium is always taken into account, but with proper ROI calculations, as we saw earlier, you can see that it's well worth it in the long run. And I agree that conservative maintenance is important to note, but often you'll find that the maintenance is more than you expect. So those are some of the characteristics. What I wanted to talk a little bit about is the charge controller's role in the system. We see it as really the heart and brains of a solar electric system. All the energy usually coming in from the panels and going out to the loads is managed or monitored by the charge controller. So we want to make sure that you've got the right settings in place. A lot of our newer products have both data capabilities as well as metering, so you can monitor all that incoming and outgoing power. And their main role is to prevent the batteries from overcharging or deep discharging. So you want to make the right decision and get those settings, because if you set them wrong, especially in the case of lead batteries, it can quickly damage a battery. And in cases where we have an alternative system here where we have DC loads, you can see that some of our larger products, such as the Tristar series, can be used to power very large power systems overall that draw a lot of energy from the battery. We do a lot of work in telecommunications, 24 and 48 volt native DC loads, and those charge controllers can be of extreme benefit here, especially when added in parallel for increased capacity. And that's where your battery investment really gets large, because you're looking at many thousands of dollars in storage, and you want to make sure that it's going to last a long time. So Morningstar uses MPPT technology in the variety of our products. We support PWM as well, but MPPT is really kind of more in demand, especially when you look at some of the modules that are coming out in the market today. The wattages are higher, the voltages are actually gaining a little bit more recently with the PERC cell technology that's being utilized in modules, and higher voltages wired in series are generally preferable for these systems for ease of wiring and efficiency. So we use our Tristar technology in all of our MPPT controllers, and that really optimizes the power output, and it minimizes conversion losses. Just as Bob was saying with having that extremely high charge rate of the battery, that comes from the fact that very little of it is converted into heat, which is a good thing. And the same is true of our charge controllers. They're fanless because we don't convert or lose a lot of energy to heat, and that really puts more energy in the battery. One other feature I mentioned earlier is that a lot of our products are data enabled, meaning we can support a variety of communication protocols. If you see some of our other telecom-based application webinars, you'll see that in a lot more detail, some of the protocols we support and the different applications, but it is a theme across a lot of our products, especially in the mid and higher power range, that you can get communications from the controller and monitor that data. And in the near future, support for direct integration with battery management systems that have data capabilities as well. And here's Morningstar's the slice of our portfolio, which represents the majority of our mid and higher ranged products that have both the ability to be custom configured for specific battery settings, such as those that are part of our ESP program, like we're discussing today, as well as used as an output for data collection, logging, and remote management and control. So these are our lithium supported products, and for each model, you will find a relevant configuration file for UPG as well as other batteries in our ESP partner webpage. So to take an example, here's our Prostar MPPT, and these are some of the lithium specific features that we've incorporated. This is the third generation of, well, I should say the third generation of the Prostar product is available, and that was a PWM design. And at the same time as the Gen 3 Prostar was released, we also offered a Prostar MPPT product with much of the same capabilities and technology. So some of the features we put in place, in extreme cold, we do have a lithium fallback feature, which won't stop charging the battery. It will just start to taper that current down until it reaches the low temperature threshold of the battery, which we don't often see actually hit, but it will actually maintain that current delimiting so that the battery can still be charged as it approaches that low temperature setting. We've got an interactive display that allows you to not only make those programming changes, but also see the status of different parameters that are in the controller, as well as have it programmed through the data port. We also offer an RTS disconnect feature, and that's an application note that we have where certain batteries that use a BMS that want to stop charging at the source are able to actually signal to the controller to disconnect charging, and they can actually manage charging externally in the controller as well. So check our website for more details on that. They're also programmable with USB or serial interfaces, and that gives you the ability to load the charge controller profile for a specific battery into the settings. And it's important to note that that's actually in flash memory. It's not something you have to do at the site. It becomes a permanent setting in the controller that'll be basically retained going forward in flash. And then lastly, a lot of our products, Prostars and Tristars mainly, include voltage sense wires. And because of that narrower operating voltage range of lithium, which is an extreme benefit, it's really important to get a very accurate voltage reading from the battery to see exactly what state it's in. So we have additional sense lines that can be run in parallel to the main charging current conductors to make sure that that's accurate. So what I'll do here briefly is go through some of the setup for the controller, and this is just a quick tutorial to show you how easy it is to load some of these configurations. And you can go to our Energy Storage Partner Program under our Resources tab on the website. You can search by brand, and then you can get the configuration files as well as detailed documentation on the support for that battery. So in this case, you can see here that this is where the configuration files are located, and you can also download Morningstar's MSView software tool that allows these to be loaded into each controller. It's a Windows utility that runs on any PC, and you can download that for free, and then of course load these configuration files from these links. So what you quickly do to install MSView is would be to download it to your PC and install it. And then once you have the UPG folder downloaded, it's a zip file that contains all the files you'll need. It's really small in size, and you can extract that configuration file and decompress all those files into a folder on the website or from the website onto your PC. Then MSView is located on this portion of our website, and that can be downloaded and installed. And the latest version is always on our website. We've made several updates over the years to support new products, but it's a quick and easy tool. Once you have MSView installed, you can search for connected devices, and that's generally done over a USB or a serial port connection. It'll auto detect the device and basically load up the data link for you. And just one quick note, we do actually support IP connections as well. So for some of our products that are enabled with Ethernet connectivity, it will automatically search the network and discover charge controllers that way as well. So that's very useful if you're on a larger system or you're setting up remote networking capabilities. So those were some detected products that were found on the local network. You click connect and the link to the controller is made, and then you're able to actually run the setup wizard. In this case, it's a Tristar MPPT, and you open the file. You're going to read from the file and load that configuration file for the UPG battery by model that you're configuring. And you can see there's the choices that were saved locally to the desktop. You open that configuration file. You can review the settings one last time in order to make sure that you're in agreement. Like I said, these have already been worked out with Morningstar and UPG's engineering team. So they're obviously well researched and thought out, but if you do want to make some changes, you're welcome to do so here, and you can browse through the setup wizard to see those different choices. If you have any battery current limits, you can also enable them here. It's less common with lithium because it can take quite a bit of current at a much higher C rate than lead acid, but it is an option if you want to do that. There is a trend because of the depth of discharge and the long cycle life of lithium. You can also limit current if you have a lot of PV and a very small battery. And then lastly, your load control settings. So once all those configurations are confirmed, you will program the product by clicking the program button, and then it will load all of the settings, it will load all of the settings into the controller, and that will be retained in flash memory and basically become one of the presets that can be used in the controller now. And it doesn't matter if power is cut or if the product is moved, that configuration file will continue to remain. Okay, so that's a brief setup of the configuration files for the products. And then lastly, I just wanted to bring up a slide here on UPG and some of their distributing partners where you can get their batteries available from, and Sunwise, Tri-State Battery, and Ameresco Solar. And many of these are also distributor of Morningstar products as well. So you can get a total system solution from these sources. Okay. Just in summary, some things to remember when you are making a choice in your battery technology and you look at all these expected, these values that are expected of the system, such as lifespan, the maintenance requirements, that figures into the ROI that Bob talked about, the space and budget. And that's one thing I not considered, when you look at the prismatic cells, the impact versus cylindrical cells. They're a much more dense and space conscious design. And then of course, the ROI. So whatever battery you're choosing, lead is still very strong in a lot of applications, but lithium support is broad and available across the industry, definitely with Morningstar's products. So you want to take into account that with your battery choices. And that is the end of our presentation. So Bob, thanks very much for covering your topics, and that is the end of my section. And what I will do is Bob can join us again now, and also Phil Golden, Director of Engineering from UPG, is also available on the call. So what we'll do is the three of us will take a look at the questions, and we'll try to take some audibly and answer those for the participants. And then any that we don't get to, we will make sure to address those later via email. Okay.
Hey, Brad, it's Mark from Morningstar. Would you like me to read the questions rather than have you all read them?
Certainly. Yeah, if you've got some good ones picked out, Mark, if you could, Bob and I can be the panel here and you can be the moderator and give us some questions, and we'll get them addressed right here on the webinar. Thanks.
As the quiet member of the group, yeah, I've been looking at the questions coming in while you were both talking. That was an excellent presentation. Thank you. And we have some really good ones, so I thought I'd go through some of them, just read them. One question that came in at the end, actually, I think is a really good one. Someone mentioned that we talked a lot about low temperatures, but they want to know about high temperatures, and specifically, will a lithium battery degrade when the ambient temperature is above 30, 35 degrees Celsius? And does the current need to be reduced or modified when the temperature rises any higher? If you can answer that one.
Yeah, thanks, Mark. And I just want to introduce Phil Golden, our Director of Engineering, to everybody as well. Phil, would you like to field that?
Sure. I think one important thing is on those field tests, they're out in West Texas and They do have very high temperatures there. But if there's any specifics on that, please just send me an email and I'll take care of your particular application.
Great, thanks. We have a couple of kind of end game questions, excellent ones from several people. I'm going to combine them. One of the audience wanted to know that mentioning that lithium batteries or lead acid batteries are very recyclable in the U.S. and one of the most, greatest success stories in recycling in general. He wanted to know what your thoughts were on recycling lithium. And then we had a second question that's a little sort of related, which is if the BMS has an MTTF of about 10 years, what happens after 10 years to the battery if the BMS fails?
Good question. I'll handle the first part and Phil will handle the BMS question. Because one of the retailers who brought in under their own brand a complete line of our lithium iron phosphate batteries, we had to put a plan in place that we will have locations around the country that it could be 7, 8, 10, 15 years from now, that battery is going to go back to a location and then we take care of what they call recycling, which there is a cost to recycling lithium iron phosphate batteries versus an SLA where you can actually recoup some cash out of the lead out of an SLA battery. But we do have that in place and we can go more into depth with that if people need that service. And then to the BMS, I'll let Phil handle that.
No, it's a great question. It really depends on the failure mode. Actually, we on purpose did wipe out one of our BMSs just for the fun of it. And it depends on the failure mode, but this one failed in a short circuit, the MOSFETs. We don't really have enough data to answer that question, but it really depends on the failure mode of the BMS.
Great, thank you. We have a couple of questions about availability. One is time between order and shipping and receiving. And we also had a attendee ask if the batteries of the UPG batteries are available in Mexico. If you care to answer that one about distribution.
Oh, absolutely. All of the distributors we showed on the previous slide have our batteries in stock, all 5 of them. So they're readily available. We also have stock at UPG. And then as per Mexico, we do not have a distributor in Mexico, but through one of our distributors, I'm sure they could set up that we could get batteries down into Mexico.
Oh, good. Maybe one's listening, and this could be a business opportunity for both of you. Got another couple of one in here that are interesting. Really, product questions. One attendee is asking, would it be possible to have bigger capacities like 500 to 1,000 amp hours? And also a second question about availability in Puerto Rico. Just came in this second.
Yeah, thank you. I will. As for the availability in Puerto Rico, again, we do not have a distributor in Puerto Rico to date, but we definitely have the same 3 distributors in the United States that could supply batteries there. And then to the first part of your question, could you repeat that? And I think Phil will handle that.
Oh, the first part of the question was on capacities. Would it be possible to have a bigger one of your batteries, lithium batteries with bigger capacity, say 500 to 1,000 amp hours?
Thank you. I'll actually take that. So as we're designing these products, we're designing them as we see demand in all channels for all applications. Every day we have more and more spec-in OEM opportunities for all kinds of products. Something from that size, we really take it and just do really a business analysis of, okay, what are the parameters? What's the application? And we work with a lot of people as partners and to help design these new products for the masses. For a one-off, I would say, yes, we could develop that. Is it on our product roadmap? Not yet, because we haven't seen where the demand would be generated from.
Sure, that's a good answer. Thanks. Yeah, one of the attendees had asked specifically about the CNI market for that kind of application. So it sounds like, there might be some viability to that. We had a couple of questions, good ones, about UL listings on the battery, specifically if they were 9450 and 1973. Could you answer that one?
At the present time, they're not. We're looking into all of that to see if, if we need to get those done or not.
Okay. We have a couple related to extreme cold weather. One attendee wanted to know about running lithium batteries at, say, 40 to 50 degrees minus zero Fahrenheit. And what might be, what that might do, or would that be possible long term? And there were several other questions about extreme cold operations as well, if you want to take a crack at that.
Well, what we'd like to do is look at the different variables. We have our test data, and we don't really have any data, any lower than that. So if there's a particular application, just please send me an email, and we'll look at that on an individual basis, because there's a lot of variables such as the application, the current battery, the housing, and all of that.
Yeah,
Sure.
and I'd like to add to that too is, what are you doing with the LFP battery? Are you just putting it out in the middle of nowhere by itself and no enclosure, no heated room? Sure, you can blow up any battery, right? When it comes to that low temperature, it's really, would you do that to an SLA battery? Because everybody wants to see how low that LFP battery will go. But I think, like Phil said, if we had all the parameters to the application and what's trying to be done, he can answer it via email.
Sure thing. And you'll want to provide the email information too at the end of the webinar, so we can get those answers in. That'd be great.
Yes, it is on the last slide, I believe.
Oh, good. Yeah, one caller, I keep saying, showing my age here. One attendee did ask a question about, and I think this is a valid one. In general, do you have a threshold for, say, choosing between lithium and lead acid or NiCad? What operating temperature range would you say, pick one or the other below this level of this threshold?
Phil?
That again depends on a lot of applications. We don't have a, set rigid guideline on that. And but you could send an email. We don't do a lot of the nickel stuff.
Right. Okay. One good one was, what inverter manufacturers do you have closed loop communications with?
At this time, no strategic partners with any inverter companies.
Okay, and let's see if we had somebody ask for contact information, but you've already provided that, so I think we're really, really good there. We have another question, which is a very good one from, and it ties in with an area Morningstar works in a lot with its hazardous locations, but somebody specifically wanted to know about using batteries in a hazardous location application or an explosion-proof application.
With details of,
go ahead, Bob.
Go ahead, Phil. Yeah, with the details of the exact, location, then we can answer that question. It's fairly broad.
Right.
If we could drill down a little bit to what locations they're looking at, we can answer them more intelligently with a lot of more information.
Sure, thanks. And we got a question in from someone who wants to know if it's required to have a BMS on board a battery the way you have.
All of our batteries have BMSs in them. It's not really required, but the nice thing about it is it really has longevity. I can take a lead battery and ruin it and less than a couple of hours, whereas the LFP with the BMS inside it is pretty much, there's nothing I can do, the user can do to destroy the battery, in theory, besides, you know, pushing it off a building.
Sure thing. That about wraps up the questions that we got. So thank you very much for responding to everything.
Absolutely, and again, we appreciate everything with everybody that attended today, and Morningstar with the ESP Partnership Program, and we look forward to emails, phone calls, and product from our distributors. So we appreciate the opportunity, and thank you very much.
Okay, yeah, thanks, Mark, for handling those questions, and Bob and Phil, again, really happy to have you join us today and be able to present on your products, the technology, and of course address all these questions. So I know all the attendees certainly appreciated it. And as we said, we'll follow up afterwards. It doesn't just stop here. You know, we can be in touch with others and maybe collect some additional information and provide some solutions on some of the topics that were requested today. So with that, on the last slide there, so there's contact information for both UPG as well as Morningstar. So I'd like to thank everyone for participating today and joining us online. And as I said, again, download the slide deck and also stay tuned for an update soon after, maybe later this afternoon or most likely tomorrow, when the webinar will be available for offline viewing as well through GoToMeeting. Okay, so with that concludes the presentation today. So thanks very much, everyone, and I'll see you next time.
Thank you very much.